Welcome, everybody. I'm Mike Honeycutt, Product Marketing Manager here at Corero Network Security. And today I'm joined by Raj Vadi, our Senior Solutions Engineer at Corero. Raj, how are you doing today?
I'm doing great. I hope all of you gentlemen and ladies joining the call are also likewise doing well. Thank you again, Mike, for the intro.
Yeah, it's a pleasure to have you today. So today's webinar is titled Beyond Network Flooding, Understanding the Application Layer Threat Landscape, right? So, I'll jump right into it, Raj. You're very knowledgeable on this area. First, let's define what is layer 7 and how is it different from the other layers in the OSI model?
All right, sounds good. This is a fundamental question when we look at, in general, networking. And I think what I want to do is kind of present, these layers in a graphic view. So I'm going to share a
Great.
slide. And we'll just quickly talk through these particular layers. So the OSI stands for Open Systems Interconnect, and essentially this was kind of like the way that networking was defined in order to interoperate with other systems. And it consists of different layers. Think of layers as a series of envelopes, one within another, like encapsulating you know,
Mm-hmm.
something at the top. Typically, when we talk about this layer, things like physical layer and data link, these are more on the network interface card and what comes off of it. And when we talk about network layer or the transport layer, we're really talking about how do I send traffic from one machine to the other. In other words, it has addressing to send it from a particular machine to another destination. So this is how you would address where that intended, piece of data needs to go. The transport layer breaks it down further in terms of selecting particular protocols, and therefore even the protocols have addresses, which essentially are services. So
Mm-hmm.
if you have a port number like 80, that's HTTP. And then as you go up, there's the application layer, which really is the data portion. Now, OSI had a more defined, stack in terms of these layers. TCP/IP, the way it was designed, and obviously some of this preempted X, Y, and Z, and so it's more of a mapping of those layers. And typically, we see like the network access layer. This is typically like Ethernet frames and things like that. Physically, how do you get from one location to the other, one station to the other? Network
Mm-hmm.
layer is a more of a logical addressing, which is what the whole internet today works with IP. Transport layer consists of what kind of a protocol. So typically TCP is session oriented, UDP is more of like a connectionless protocol. An application layer is simply the data that is being sent. So when you ask for a web page and you get a response, that's in the application layer. So anyways, that's really, I hope, a brief summary of what these layers are, and sets the tone going forward.
Yeah, and so you briefly kind of touched on protocols there. Can you go into some of the protocols that you mentioned there, or were sort of alluding to?
Mhm, mhm.
So the
So
HTTPS and all that.
absolutely, absolutely. So today, when we talk about the internet and when we talk about applications, the very fact that we are even talking on this particular session here is being carried across HTTPS. HTTPS, basically stands for HTTP, and the S is secure. Secure is essentially where we are also creating a data encryption layer. Typically, that's part of what today is called TLS, or transport layer security. So generally, this preserves the confidentiality of data that we are carrying across. And from a confidentiality perspective, this data is not in the clear text. It cannot be observed even if somebody else has it. It's only between the two endpoints, whether that be a web server like your banking server and your browser, and everything else in between is encrypted. In fact, I think the development of TLS and its predecessor SSL is what led to the massive explosion of internet, because that allowed commercialization of the internet into carrying out online transactions and so on and so
Mm.
forth.
Thank you for explaining that. And so, today's webinar is titled Beyond, flood attacks, right? Which is how we think of traditional DDoS attacks. But why are attackers increasingly going after layer seven? And specifically speaking to, we're not talking about floods at this point. So can you dive into that a little bit more?
Sure, absolutely. So typically, again, when we talk about DDoS, and I should say from the term denial of service, denial of service can happen anyways, right? Network floods
Mm-hmm.
is one of the means by which denial of service attacks are carried out. However, the objective is to really deny that service from being accessed by legitimate users, right?
Right.
And typically, I think over the past 15 to 20 years, maybe even a little bit longer, but over the past 15 to 20 years, it has been very concentrated in the network and even maybe a transport layer floods, in terms
Mm-hmm.
of like whether we call like things like SYN floods or UDP floods and things like that. The main reason for this is one of the issues on the internet is typically, just as the US postal system does, nobody verifies your sender address, which really means I can pretend to be anybody else. So basically spoofing. And this is the
Mm-hmm.
difficulty in trying to figure out who's real, who is not. And most of these network floods in the past that targeted this particular, I would say like the maybe, I don't know if it is a shortcoming or a vulnerability, but nevertheless, it was exploited as a vulnerability to send massive amounts of packets towards a destination host. And today, because of the advances in, number one, mitigation technologies, obviously even vendors, the advent of the cloud, the ability to hyperscale, some of these network DDoS attacks are no longer, I mean, they're still very prevalent, as you may know, even with our own, security report. They're still out there and probably breaching scales of several terabits, maybe even getting into like closer to the 100 terabyte range. Um, but the mitigation strategies are much more effective today than they were 10, 15 years ago. What the attackers are trying to do is now to get to the next phase, which is attack the application layer. So, you know, they understand, and because most of the mitigation technologies today at layer 3, layer 4, you do not really see the data, nor do you decrypt or can look into that particular data, right?
Mm-hmm.
And so trying to flood at the application layer, imposes heavy costs on the server, because it's no longer just processing data, but it is also terminating, decrypting this traffic. These are processor heavy, operations, especially when we talk about public key, which is involved in this whole, cryptography issues. And this is really what is causing the denial of service. You don't need a whole lot of volume. You don't need to be terabits of traffic in order to bring down servers on the TLS layer, in terms of sending, junk requests and things like that, excessive requests. And by the way, most of this is manifested through botnets, IoT devices that have been compromised, because there's a lot of IoT devices that have, default credentials and so on and so forth, and that can be easily compromised to become,
So,
attackers.
question there. So it seems like it's more precise in nature, right? And so is this because the attackers have gotten smarter, or the sort of the democratization of being able to do this, or is it a couple of things that are taking place here as why they're specifically targeting layer seven and why it's more effective now?
Sure. I mean, so layer 7 has been targeted typically for intrusions, right? I mean, in terms of like whether it is injections of like malicious code, malicious traffic, ability to exfiltrate data. And typically that's not a volume kind of thing, but more of an intrusion attempt. However, the very fact that they had the tools to exploit these kind of things, they have kind of merged, or melded, typical DDoS network tools used to be back in the day, like, and a few other kind of like, tools that could blast at volume. Now they have adapted that to be able to establish TLS connections and that, mount attacks. Even before the encryption part, they could still, even the setup can be exploited. So these are like, TLS layer attacks. And so, these are, again, expensive on the processor. And typically, even from a mitigation perspective, when you start decrypting traffic, you are going to pay a cost in order to terminate all of that traffic, inspect it, and let it through. So it does require for more novel ideas in order to handle this at volume. One of the ways is to also examine and, at the TLS layer, this is before the encryption setup happens, and to try and filter away a lot of that content. In terms of the encrypted traffic, there's again other mitigation strategies to deal volume or these kind of like, DDoS.
I appreciate that. I mean, give me a real world example, right, of this sort of layer 7 attack, like something that we've seen here at Corero, or you've seen in your experience, the style of attack and the impact that it's had on the business or the organization.
Sure. So again, I typically don't like to name who our customers are, but let's start with like, in terms of like these kind of attacks, what we have observed even at Corero from a SOC perspective, right, is first, it's no longer a single type of attack. It is a multi-vector attack, right? There's multiple attacks happening at the same time. And while we are mitigating like, more of the network layer stuff, because they tend to be the majority of the bulk of the traffic. Why is the volume less for application traffic? The reason for that is typically this setup, a request for an object or something comes in at a few kilobits, somewhere, let's say about 2 to 3 kilobits, per request. And even if you had, I don't know, 10,000 or 200,000 of that, it still doesn't account to a terabit kind of range. However, the amount of processing for each of these new TLS handshakes is high. Now, we have seen this kind of thing where we have mitigated all the network, layer floods and stuff, and still the customer is like, kind of reporting, hey, we're still having an issues with this particular service. And so when we start looking at that traffic tends to be a lot of 443 traffic, and 443 is the port on which HTTPS works. Now, in order to actually look at that traffic, one of the key things that any mitigation appliance needs to do is to decrypt that particular traffic and look at that thing. I think this is where, Corero can brings in some unique capabilities where, we selectively decrypt traffic based on our understanding of the network layer traffic, because we see a bigger picture of the network layer traffic. We select certain sources, and then, terminate those sources to examine, are they sending us good requests or bad requests? And then make a determination based on, number of requests, what exactly are they doing? Is the TLS layer clear, or are they attempting even to do some malicious stuff at the TLS layer? And then kind of, known bad sources, we're going to kind of put them in a temporary or an ephemeral jail, right? So for the next 5 minutes, this IP is going to be suspended, blocked from sending us any traffic. If their behavior changes, that's fine. We can still pass through. But, the idea here is the more number of hits come from this, it's like a penalty score. The more bad things you do, the longer you're going to get blocked out. But the idea with this is to keep a very high volume of traffic flowing through for good legitimate traffic, while still, sampling, selecting things and blocking out bad traffic based on our understanding of the network. And this is based on our existing Corero DDoS technology. That's how we do, even for network layer floods and other stuff, identifying what those bad sources are, what is the destination that's getting attacked, and so on and so forth.
So this is a good segue, because we got a question about, regarding where we sit in the topology. So how we deploy and we're able to see this, and you're kind of touching on this. So how do we see these things in the architecture? Where do we sit to be able to see this and be able to inspect and
Mitigate
detect?
these.
Yeah, yeah.
Absolutely, absolutely. So one of the ways, and I think this is kind of unique to Corero in terms of how we have always deployed within a network. Generally, I mean, Corero has been like, I think our majority of our customer base has been service providers and so on and so forth. Doesn't mean that it doesn't apply to enterprises. Large enterprises have similar infrastructure. So one of the things that we do is basically we have mitigation right at the edge, which means
Hmm.
that we are able to, for generic routers, we can send some flow spec messages. Again, things like IP addressing, so destination, some amount of payload where we can, again, be aware edge mitigation will not mitigate TLS attacks because there is encrypted content, but I'm building up this stuff in terms of layers. So we have the edge mitigation at the router layer that will clean out most of this traffic. In fact, that will take care of quite a bit of network layer traffic. The next phase is traffic that is still passing through. We are able to inspect because we have telemetry from these routers, so we know what was blocked, dropped versus what was still passed and is still anomalous. That
Hmm.
traffic we can actually redirect to a scrubbing center. And this scrubbing center, the way we would set it up when we want to focus on TLS, if we didn't, the scrubbing center could have an asymmetric flow, which basically means in traffic would flow in through the scrubbing center, but not necessarily out through it. However, when dealing with things like TLS, because they are session oriented and session based, we do need to see symmetric traffic. So this is how in large enterprises we would do it, which is a remote mitigation versus redirect and mitigate within a scrubbing center to pass the clean traffic and ensure the responses to that flow back through that scrubbing center. For most other enterprises, we can go in an inline configuration, which means we are either physically inline or we are in line in a logical manner with a, we have something called data path where we can be a sidecar to a router, or
Hmm.
we can also have traffic being routed in and out of us, depends on how the routing infrastructure is set up. But the main key thing is in order to mitigate application layers, attacks, floods, DDoS, we do need to be in a symmetric manner and in line with the flow of traffic and have to see all packets because generally we do sampling for layer 3 and layer 4, but for layer 7 we do need to see every packet coming through in order to mitigate this. But this is the structure, so we have a full comprehensive story how to mitigate multi-vector threats and do so in different parts of your network.
Very well said. And so the next question I wanted to ask is around, and you touched upon service providers and enterprises, right? So you know, it may seem obvious, but what are the risks associated to ignoring layer 7? So if you're relying on a traditional solution that's basically just 3 and 4, right? But so you're ignoring layer 7, but then also from a provider perspective, it's also a differentiator if you have a more comprehensive solution that's also looking at layer 7. So maybe you can talk to
Sure,
that.
absolutely. So when we work with service providers, carriers, telecoms, and we do have also partnerships with a few of these. The idea is, within a service provider cloud, we don't want to kind of necessarily target all of the TLS aspects of it. So we would look at the TLS protocol layer itself, mitigate attacks. So it provides a certain amount of mitigation in the carrier space. And
Hmm.
generally, as a hybrid solution to that, you would either have an on-prem appliance at the customer premise end. Why? Because by this time, a majority of the traffic, remember, as I mentioned, application DDoS, it doesn't involve volume. It's not, even if it is a lot of requests, typically the data volume is not the same as a network flood. So it would still reach the on-premise and would be with a inline appliance for the smaller enterprises be mitigated right there. For the larger enterprises, it could be a scrubbing center within those particular enterprises. And that's generally how we would set it up, so that it doesn't put a burden on the service provider of having to deal with certificates, offloading, and so on and so forth, right?
Uh-huh.
However, if carriers are okay with that, maybe they want to provide dedicated services to their tenants. That's certainly something where they can also put a scrubbing center, handle certificates on the box in the environment, and be able to scrub that particular type of traffic. Does that kind of cover that stuff, Mike?
It does. It does. I mean, I think that's the whole point is understanding the value from both and what we serve and who we serve today, right? Because you're
Yes.
right. We have traditionally served service providers, but we do have a solution for enterprises. I just want to make sure we underscore that.
Sure.
We have a great question from, and I hope I don't butcher his name, Ram Apala.
Hmm.
He asked Raj, please share how the solution is different from AWS WAF and what additional advantages does it provide? And
Hmm.
so I'll let you answer that, and then he has another follow up. So
So
how's it different from AWS WAF, and then what additional advantages does it provide?
absolutely. So first and foremost, Ram, just to clarify, number one, the solution we are talking about here, again, we have to focus on the DDoS aspect at the application layer, which is not quite what a WAF does. A WAF is more focused on intrusions at the application layer, and even more advanced stuff in terms of like things that may show up after a few transactions, nested requests. It could be JSON issues, it could be API. That's a completely different sphere. What we're talking about is, number one, how do you prevent like bulk requests coming in? And that's really the focus of an application layer DDoS. So that, number one, would differentiate what is a WAF in general, regardless of AWS or any other WAF, versus what an application layer DDoS mitigation appliance or solution is. The second part to that, you know, do we need to send traffic? No. I mean, so the way the Corero solution has functioned is, there's, generally we don't have a cloud of our own. However, we do operate with cloud operators. We partner with Akamai. So if you're an Akamai customer, there would be certain amount of mitigation that takes place within the Akamai cloud. And then Akamai also has what they call as Prolexic on premise, right? And the Prolexic on premise is the Corero, device solution. It could be virtual, physical, whatever it is. But this is a on premise part of the solution on the customer side. And so traffic that has been mitigated for layer three, layer four, the bulk mitigations, right? UDP floods and DNS and so on and so forth. And when it starts getting to the HTTPS traffic, this HTTPS traffic would then be inspected, selectively terminated, and if malicious traffic is found in that, those kind of malicious sources would be blacklisted, for a temporary time period, and that's something that can be defined, and allow through anything else that looks legitimate. So again, this determination of who's good, who's bad, that's based on algorithms that Correa has developed also for layer 3, layer 4 over the years, and we use similar logic in terms of looking at suspicious or anomalous traffic.
Can we talk about the time there? Are we adding latency when we do this, or like so for the time to create this sort of jail or penalty box? I mean, can we go into that because speed matters?
Yeah. So let's talk about, generally in terms of like, the detection itself. Typically, when we are in line, the detection is sub-second in terms of figuring out what seems to be, an anomalous set of sources, right? It doesn't have to be a single IP. We can look at multiple such sources. Generally, if it's a botnet, that's the case. Once those are selected and we choose to start terminating that particular traffic, right? Um, is there going to be some latency? Yes. I mean, obviously, if you terminate traffic, it is going to be there. However, be aware, like, things like, for example, when we look at the TLS layer itself, right? Let's say we want to make sure that your handshake or TLS handshake is looking good. That does require a whole lot of latency, right? Because there is no encryption involved at that layer. If we need to focus on traffic post encryption, that's where we need to actually get into that encryption layer and select it for decrypt and inspect and re-encrypt also, right? So we want to be a bump in the wire. Um, but remember, we do this selectively and not on an ongoing basis. In other words, we don't become a reverse proxy for all traffic. That is a key distinction between our solution and some of the other solutions that are out there. Because if you do become a reverse proxy for all traffic, you become the bottleneck in the work. Our
Yeah.
idea here is select, sample, observe. If you're bad, you're going to be blocked on your source IP in this ephemeral jail for a brief period of time, right? Obviously, if there's more hits to the source, in other words, more of those packets keep getting blocked, you want to stay in that jail for a longer period of time, right, before you're inspected. Uh, but the benefit of this is because we don't terminate all traffic passing through us, legitimate traffic experiences no latency. It is whatever latency your application server has, go straight to the application server. I think this is a huge benefit where we provide this capability to inspect encrypted traffic for floods. At the same time, you're not becoming a bottleneck in that traffic flow because there may be thousands of these HTTPS, lots of servers, hundreds of servers out there. And we only want to pick anomalous traffic patterns, inspect that. And if we find malicious traffic, we put that into a bad actor, jail. And if, you know, your legitimate traffic pattern and things like that, there's also a good known IPs. But generally speaking, we are picking those anomalous sources. And normally, I would say the percentage of good traffic in that is kind of low. That's why it's an anomaly in the first place, right? But there may be incidents where I don't know, maybe it's like you just released a new product, there's a flash crowd and things like that. So important part is we want to make sure what is at the application layer. So we don't want to like block just because you're a flash crowd, right? At the end of the day, this is about picking out those kind of requests that are malicious, but not necessarily not impacting legitimate traffic. So again,
Great explanation, Raj. And so the other thing that would be on everybody's mind is ease of use, right? That's another thing that everybody's always worried about. Are we adding more complexity to our teams? It's another resource, you
mhm,
know. So in terms of the Corero solution and the differentiator that we bring,
mhm.
you know, how can an organization simplify their layer 7 defense with something like what we're offering?
Yeah. So one of the, I would say, the hallmarks of the Corero solution, right? Think about our target market. Our target market is service providers. Service providers don't have the luxury of a very large workforce, right? And
Hmm.
anything that is a complex solution and has a heavy operational burden or cost, at the end of the day, it doesn't cut it for them. And the fact that we are present in various different carriers can scale the solution, even at scale. This is a very logically designed solution, goes based upon policies. And you have different objects like routers where you can mitigate this traffic. You have like scrubbing center, which consists of series of our appliances in an inline thing. But generally, outside of the setup that may take, in general, I think it's a few hours. uh, we haven't had a whole lot of of our operators having to be burdened by doing a daily management. Second thing, I want to underline the fact that we provide also a fully managed service, and this is of
Yes.
great value, especially when we are talking about things like layer 7 attacks and so on and so forth. The skill set and the knowledge required for that is a completely different game. And I think we can add to that, not just simply throwing a solution, but adding that human element, bringing in the skill set, and assisting you during your time of need without having to point fingers or read the manual or X, Y, and Z. I think that's a great value that we can provide. And it is reflected in terms of our customer retention rates of like 97%. I think that's a spectacular number out there.
Yeah, absolutely. I'm glad you touched on that. I mean, the whole point is to be proactive and not reactive, right?
Right.
And then to not add more stress, right, to your team.
Or operational
So
burden.
exactly. So Raj, we're at time, but I want to give you a chance to kind of close out and give a call to action to anybody who's watching today. If they have questions, what would be next steps for them, and if they want to continue this conversation.
Absolutely. So I think it is key, and I'm sure there's questions. There's always questions. Hopefully, we have thrown some light on this topic. But in order to continue this particular dialogue, I would strongly urge you to reach out to us. You can go through our website. You can register your questions. There's plenty of ways to do that. You could also reach out to various partners where the Corero solution is present. Right. I mean, in terms of having to talk about what it is that we bring to the table. And I would strongly suggest, I'm available as a resource anytime anybody wants to have a conversation on this particular topic. And we can delve into the depth of the solution, your particular challenges, and how we can offer solutions to mitigate that. By the way, I know like we had a question about the WAF part. I also know that we're working on some of the interesting solutions to this issue and problem beyond what the traditional solutions today offer, and would be glad to talk about that. But I think, Michael, if I'm not wrong, we also have a series of these,
Correct.
chats going on. So I think I would urge anybody who's there to please also join in and participate in these ongoing series.
Raj also does marketing, everybody. But yes, you're right. This is the first of a three-part series. So we're going to continue this conversation around layer seven. So we'll get into some of the things that Raj touched on there, or specifically around the web and application security. But this has been a fantastic chat. Once again, if you're watching and you're curious and you want to talk to us, we'd love for you to talk to us. And we take a fully consultative approach, if you can't tell. Raj and the team here at Corero are truly experts and would love to walk you through our solution and full set of capabilities that are unique to your business and your challenges to address your pain points. So if you go to Corero.com, click on the Speak with a Specialist button, somebody would be glad to reach out to you. And stay tuned for the next episodes of part two coming up in a few weeks. Raj, it's been a pleasure, and we hope everybody has a great day. Thank you, Raj. Thank you, everybody.
Thank you all, and thank you for your time, and have a great day.
Bye-bye.